Hello everyone, I'm Sebastian Y and this is Managerial Economics. In this video we're going to talk about ordinary least squares and how we use it to calculate regression estimates. In the previous video we showed how to estimate a bivariate equation that looks something like this. We used Excel and came up with an estimated equation y hat equals beta naught hat plus beta 1 hat x. We just let Excel do its thing and get those numbers for us, but now we're going to talk about what's actually going on under the hood. The technique that's being used is called ordinary least squares. Ordinary least squares, or OLS, is an optimization, just like the other minimizations and maximizations we've done previously in this course. This time, it's a minimization. The idea behind this is to select a beta naught hat and a beta 1 hat that minimizes the total amount of variation that the regression misses. We measure that with the residual sum of squares, or RSS. RSS is the sum, and we use this big sigma sign here to indicate sum, across the entire sample. So we start at I equals 1, and then go to 2, 3, 4, all the way up to n, and add them all up, of EI squared. That is the residual squared. In the previous video, we defined EI as the actual value of y for observation I minus the predicted y hat. So minus this y hat right here. So minus beta naught hat minus beta 1 hat xi. So we're going to plug that in, and what we get is the sum of yi minus beta naught hat minus beta 1 hat xi, and square that whole thing. Remember that EI is the amount of variation that was missed for a single observation. Sometimes EI is positive, sometimes it's negative. Squaring them is going to make them all positive. And then when we add them all up, this gives us a sense for the total amount of missed variation across the entire sample. We want to make this as small as possible. As with any optimization, the way we go about that is by taking the first order conditions. We have two choice variables here. We're trying to select beta naught hat and beta 1 hat. So the first thing we're going to do is take the partial derivative with respect to beta naught hat. To take this derivative, there's a few things to remember. The first thing is that when we take the derivative of the sum of a bunch of things, we can take the derivative of each of those parts separately. This means we can basically ignore the summation and just tack it on right here at the front. And then we're just going to take the derivative of the part that's inside and then add all those up. The way that we're going to do this is with a calculus rule called the chain rule. This means that when we have a function inside of another function, that's the squared in this case, we just take the derivative of the inside. So the derivative of just this part with respect to beta naught hat is just negative 1. So we're just going to throw a negative sign out here. Then we essentially pretend that it's just an x inside the squared and take the derivative of that. So the derivative of x squared is just 2x. But then what we do is we plug all of this stuff right here into the x. So we're going to get that 2 on the outside, and then we're just going to put everything else on the inside. And then, of course, we subtract 1 from that exponent. That's our derivative. For the first order condition, we set it equal to 0. We're going to do the exact same thing for beta 1 hat. I'm going to skip over all the calculus details this time and just write it out. What we get is minus 2, sum from 1 to n, of yi minus beta naught hat minus beta 1 hat xi. All that stuff's the same. But this time on the inside, we had not just negative 1, but negative xi. That negative is still hanging out on the outside. Again, set it equal to 0. We now have two equations with two unknowns. Two unknowns are beta naught hat and beta 1 hat, and then we could do some algebra to figure out what those things are. For the purposes of keeping the video short, I'm going to skip the algebra and go right to the solution. The solutions we end up with are beta 1 hat equals sxy divided by sx squared. So what do these things mean? Sxy is the sample covariance of x and y, and Sx squared is the sample variance of x. These are things that we can use Excel to calculate for us, which we'll do in a minute. Beta naught hat is y bar minus beta 1 hat x bar. Beta 1 hat we've just calculated, that's this, and y bar is the sample mean of y, and x bar is the sample mean of x. These are also two things that we can easily use Excel to calculate. This means we can go over to Excel, calculate these four things, and plug them into these two formulas here, and that's going to give us our beta 1 hat and beta naught hat. If we do this correctly, this should give us the same result as the regression, and this will serve to illustrate what exactly Excel was doing when we click the regression button. Let's give this a try. The first thing we're going to need is the sample covariance, so we're going to use the formula covariance.s, S stands for sample. Then we're going to need to select all the data for the two variables. For us, x is price and y is quantity. You can do them in either order, it does not matter. We'll do quantity first, so I'm going to select this entire column. Then we put a comma and then select the entire price column. Close the parentheses, and that's going to give us our answer. Next, we need to do the sample variance of x. Remember that x is our right-hand side explanatory variable. In our example, it's the price. For sample variance, we do var.s, again, S stands for sample, and we select the entire column. Make sure, again, to be careful that you're selecting the explanatory variable here, not the dependent variable. That's why we're using price. Now that we've calculated both the sample covariance and the variance, we are ready to calculate beta 1 hat, which is the covariance divided by the variance. And we can see that that matches up perfectly with the answer that Excel gave us. To get beta naught hat, we're going to need to get those two sample means. So I'm going to use equals average to calculate the mean. Let's do our y bar first, so that's going to be quantity. Select that whole column. And then let's do x bar, which is going to be the average of all of our explanatory variable, which again is the price of x. We now have everything we need to calculate beta naught hat, which is y bar, so that's this one, minus beta 1 hat, which we already calculated, times x bar. And we can see that this answer matches up perfectly with the answer that Excel gave us. The whole point of doing this is to show that regression is not magic. Even when we let the computer do things for us, we still want to understand what it's doing and why. I've now moved over to another sheet that you have in your demand Excel file called OLS Demo. The purpose of this sheet is to just give you a chance to play around with different values for beta naught and beta 1 hat, which will serve to illustrate what Excel is doing when it is minimizing the RSS. So what I have here is two yellow boxes that you can type any number you want in to make a guess for beta naught hat and beta 1 hat. Of course, we know what the answer is going to be. That's the OLS solution right here in blue. But let's just guess some other numbers. So let's say 3,000 and -5. And every time we do this, it's going to play around with that regression line that you can see in orange. You can see that this line does an okay job cutting through that blue cloud of points, and it has an RSS given right here. Remember, that's the sum of these squared residuals, and that's this column right here. Let's change some of those numbers a little bit. So let's make the slope a little bit higher, and you can see that's going to reflect itself on our regression line. But it looks like it's a little too far to the left, so let's increase this to 4,000. And that's looking pretty good, right? You can see that our RSS is a lot lower than it used to be, but it's still not quite as low as the one from the actual solution. It's pretty close though. And so as we tweak these numbers a little bit, we can find that our RSS keeps coming down as we get closer and closer to the OLS solution. And so essentially what Excel is doing in the background is playing around with that orange line until it gets it just right to minimize the RSS. And that is how we use ordinary least squares to figure out the estimates for a simple regression. In the next video, we're going to move on to multiple regression.